Designing, manufacturing, installing, and maintaining the high-speed electronic computer, the largest and most complex computers ever built.
Hello, everyone, and welcome to the Building Better Systems podcast, where we chat with people in industry and academia that work on hard problems around building safer and more reliable software and hardware. My name is Shpat Morina.
And I'm Joey Dodds.
Joey and I work at Galwa. Galwa is a research and development lab that focuses on high assurance systems development and broadly hard problems in computer science.
Today we're chatting with Jordan Kyriakidis. Jordan's the co-founder and the CEO of QRA Corp, a software company that's helping engineers to write clear requirements. Jordan and QRA Corp are developing a product that's called QVScribe. And what it does is helps you write requirements and then analyze those requirements in order to help answer the question, do these requirements actually describe what we want to build? And are they useful as requirements down the road? Or is there anything missing? Today, we chat with Jordan about what the impact of writing good early stage design requirements is, how they impact your system, how you can write better requirements. And then we'll also get a little bit into the state of neural language processing and machine learning. And then how we apply those in situations where you need explainability and where ambiguity is unacceptable. Thanks for joining us, Jordan.
Pleasure to be here, Joey and Scott. Looking forward to our conversation.
Yeah, we're excited to chat to you about requirements today. And I'll start maybe with a question that might seem a little silly, but early stage design and requirements writing is somewhat critical. What makes it critical?
It is critical, and it may not be the most fun part of the engineering process, but it's critical because it is the first time where you capture the intent. We start describing what is it we want to do, right? And what behavior do we want for a system to have, especially if the system or product that you're building is very complicated. It involved, oftentimes many years, many engineers, oftentimes a whole supply chain, so different companies even, and you need to make sure that everyone understands what it is you're building and that you're building the right thing, and make sure everyone's on the right page and have a common understanding of what it is you want to do.
At QRA, you're essentially building a product that is supposed to help with that. Can you tell us a little bit about it?
Sure. We started solving this problem of, you can call it design verification, if you will. It is, how do you know that what you build is the right thing to build, and what you build is going to have the behaviors that you want it to have, right? So how do you figure that out? When we first started, we were thinking the problem was in the design. So we ended up building something that verifies designs, right? And these are usually Simulink models for the dynamical system, these types of cyber physical systems. And when we put it into the market and got it into customers' hands, what we found the way they were using it was comparing their designs with the actual textual requirements. And what we found was at least half the time, sometimes even more, the error actually originated in the requirements, not in the design. And my background in training is in theoretical physics, so I have this kind of irresistible urge to get down to fundamental and first principles. And so I said, okay, well, we wanted to solve things right at the beginning in the design. It turns out there's even earlier stage of requirements when you're just basically trying to decide what is it you want to design. And that's where we kind of moved the company over to start looking at the requirements. It means a whole other set of technologies you have to adopt, more NLP, and to really analyze the requirements to make sure that, the intent is very clear from all possible stakeholders.
Is that the main kind of benefit? How would you characterize what people would get from using the product that you're building?
So I would say at the highest level, the benefit is they would save time and money, right? So they would save the rework costs, right? That is the main thing. So oftentimes, and I'm sure at Galwa, you guys see us a lot as well, that you insert these errors into the development process very early on, but you don't know that you're inserting those errors, and you don't have any mechanism to catch these errors until sometimes years later from another person who had no involvement in the early stage requirements of design, uncovers the error, and then you have to go back and rework what you've done before. Saving that time is a big benefit that our customers receive.
At the highest level, in a way, that's a lot of products are their goal is to save time and money. If we get a little deeper, if you're somebody writing requirements, is it a matter of clarifying the intent? Is it a matter of checking for ambiguity? What are those benefits? I'm curious.
So the benefit is really consistency and clarity and conciseness, right? So there's several, currently we check 16 different problem types, we call them. So for each requirement that you would write, we'll go through and apply these metrics. We analyze it to these 16 problem types, and we'll produce a score of it. So typical things that we check for is it, are you saying something that is ambiguous, can be interpreted more than one way? We'll dock you some points for that. Is your requirement non-atomic, meaning the requirement should be broken up into multiple sub-requirements. Each one is atomic. So every requirement should require one and only one thing. Typically from requirements, that'll get passed on to the test engineer, and the test engineer will build tests. And so if you have a requirement that says, if this happens, do this, unless you have this feature, in which case do this, but only under these conditions, otherwise do that, right? We've seen requirements that are kind of structured that way, and we say, okay, this is actually 5 requirements. And so our product will go there and say, okay, break this up, right? Other times the non-functional requirements aren't specified. So they'll say, if X should happen immediately, Y should happen next. Now, what does immediately mean, right? Other times we can check for ambiguity. Actually, what we do check is for similarity, but oftentimes requirements that are very similar are also contradictory, right? And so we can flag ones that are semantically very similar, and we can flag those. And so it's a series of checks that you do very early on that really are almost like guideposts for the author, so that they catch a mistake right there as they're typing it right away, as opposed to later on when they're in a review meeting or deeper into the engineering process.
And the feedback is that quick. So as someone's typing out requirements, they'll get feedback from your tool. Is that the turnaround that you give?
It is nearly that. There is an analyze button that you have to press now, but we're looking in future releases to get rid of the analyze button, to just keep doing it just in the background, right? And to get it really, but it is right there. We produce a score from 1 to 5 on each and every one of your requirements. So as you're either reading the requirements or writing the requirements, you get the score right there to actually, to assess how well your requirements are written.
And I haven't, so I guess I'd say personally, I haven't put a lot of thought into how I write requirements. Some of the things you mentioned feel like they're obviously good things, right? The sort of repeating if statement that you mentioned, all being in a single requirement. It seems like it's suggesting a lot of the code, and maybe suggesting a not very good structure to the code that would be better left to the engineer to figure out in the long term, for example. How, when you come up with these lists of things that you want your software to help with, how, in that case it's obvious, in other cases maybe it's not so obvious. How do you evaluate how good a requirement is? Because it seems like you're aiming for certain things by applying your tool, but how do you know those are the right things?
Well, I guess the ultimate arbiter is our customers. They tell us if they're good or not. But there are some rules of thumb that we can apply. For example, there are international standards. I don't mean official like ISO standards, but in COSI, these kind of systems engineering societies, they publish guides on, based on our experience, here are the characteristics what a good requirement should have, right? And so we can take some of those and we can code them in. A lot of them are taken from that. A lot of them are things like, you should use active voice instead of passive voice. A lot of companies have their own internal guides that they use on how to write requirements, almost like style guides. And what we were actually very surprised on is how many industries have very similar guidelines and adopt similar practices in writing requirements, right? Whether it be energy companies or medical device companies or even automotive, they all kind of have a similar flavor of it, which is good for us because that means we can apply one set of processes that apply for all of them. Looking back at it now, maybe it's not so surprising because in the end, it's all systems engineering, right? And there is an established practice for systems engineering.
I'm curious, actually, if maybe this is too much in the weeds, but it might be interesting for some of the listeners. It sounds like you've seen a lot of different sets of standards and guidelines. That's a broad question. Out of those, what stands out as your rule of thumb? Like, here's the top X things. When you're thinking about how do you write better requirements at the beginning, you got to think about these things. I wonder if you could talk a little bit about that.
Yeah, I would say it's a lot of it is just a simple structure of the requirements. A lot of them are written almost like prose and will help and actually chop it up into individual pieces. Oftentimes we find that the requirements are sometimes, I don't know, I want to say too specific. I don't really mean too specific, but they're more specific than the writer actually intends them to be, right? Like, especially in the very early stages, you don't actually know all the details of what you want to build, right? And so you have uncertainty, not in the language that you're writing, but in your own mind of what it is you want to do, right? That type of uncertainty the requirement should not be more specific than what you think, right? So sometimes always having vague requirement is not always a bad thing. It's bad only when it's more vague than what you actually intend it to be, right? So that's one that I would say was a surprise that being in this game for a while that I found. But really I would say the I call it atomicity of the requirements is probably the biggest thing that we see, and having imperatives, meaning oftentimes requirements you read it and it doesn't actually require you to do anything. It's just sort of a statement of of what should actually exist, right? It's not actually a requirement, right? Yeah.
So number one on the list, have it be a requirement.
It should be a requirement, and it should be written sort of in an imperative style, right? And so, some companies even insist on using the word must or the word shall. Some of them are very specific and actually have individual words to use. And so, if you can't write your requirement as they call it shall statements, it's probably not a requirement, right? And I would say a close second would be vagueness, right? Using vague words, and the big culprit there would be non-specific temporal phrases, right? Things like instantly, or if X should happen, Y should happen, and they usually say something like immediately or soon, or soon enough, or adequate. Efficient is another kind of word. These types of kind of vibes in the requirement should be kind of eliminated. So a lot of it's kind of that qualitative nature.
And so what you're highlighting with these points to some extent to me is that the requirement writer's job is not an easy one, right? Because there was sort of a too specific, there was a not specific enough. Like, getting these things right is a sweet spot, right? And so, right, because
right.
You don't want to overspecify. You don't want to say you should use this very specific thing when that's not the requirement writer's call to make. But if you're too vague in temporal things, for example, then you can cause real issues for the system down the road. And as a newer requirement writer, or even maybe more experienced one, it wouldn't be obvious which kinds of where it's right to be abstract and where it's right to be specific. It sounds like it is a real challenge for requirement writers.
It is a real challenge for requirement writers today, and it's so there are certain trends. I would say in the systems engineering community. One trend is that all of the older experienced engineers are retiring, so there's new people coming in. And there are also a lot of companies have requirements authors whose native language is in English, so they're also new to writing. So there's a training component and a language barrier as well, and this actually helps them. But it's not it's not a silver bullet. It's not like if you use QVScribe, then all your problems are solved, right? You still need the human in there. You still need judgment. For example, we can't tell you, not today at least, that your requirement is correct, right? Because it's a piece of software, doesn't know what's in your brain, doesn't know what you intend, right? But it can tell you, it can actually surface things to let you think about this, right? We say immediately, what do you actually mean? Is it like a nanosecond or is it a minute, right? I was talking to one guy yesterday, and he was saying that for them, it had immediate, but really they mean like 10 minutes, right? That's what they mean. It's like, not a couple hours, but it doesn't have to be a nanosecond either, right? It's just the time frame that the response time was sufficient, right?
You touched on this thing where it was like, I guess when you build tools like QVScribe, the tough part is when it comes to it's, too vague or not vague enough. Mm-hmm. There is no way for you to really know that because it's all about intent. And so it can be, I'm assuming it can be just you press this button, it's done. It's sort of a loop. And so you got to make this thing that really works well with the requirements writer. I wonder what that's like or what the challenges there are.
So there is a challenge there, and different tool makers offer different solutions. So the solution that we adopt is to make the tool configurable, right? And so you can control how deep an analysis you want to do, or how stringent an analysis you want to do. And you can basically have some level of configurability there to make it. And the configurability happens in two stages. One is that different companies have different policies and different needs, right? If you're designing an emergency shutdown procedure for a nuclear power plant, right? You want to be very stringent. There's no room for misinterpretation. That's where you want to do something very formally and prove that this is actually going to work. But if you're doing something that, if it goes wrong, it's not that big a deal. You don't need a big 200-pound gorilla to, formally verify everything. So you can relax it a bit, right? So that's kind of one thing, the project or the company or the system you're building. Another one is the stage of development of the product or system you're building. Earlier on, you may want to be a bit more laxed because you're still just very early stages. You're just starting. You don't need to turn off all the checks. But as you're getting closer to baseline and closer to actually building it or setting it out to your supply chain, you want to be a bit more stringent there. So I kind of liken it, to like compilers. You have a element of how pedantic and how stringent you want to be to these compiler checks. Something like that is the option that we're going. Other methods that are used are just do it by machine learning. So you learn from the individual company or the individual authors over time. That gets a little better. Right? Those are a lot more vague, a lot more difficult to quantify, but that's another option. You can do it, right? So over time, it conforms to the user's ability. The tricky part there is you want to conform to the good requirements writer's ability, not kind of, the ones that aren't as good.
So actually that gets me into another thing that I'm curious about. In QVScribe, you rely on kind of the latest and greatest in natural language processing to do all this. In addition to that, I know you're thinking about how can we use kind of machine learning in general in situations where the results have to be a little bit more, they can be, ambiguity is unacceptable. I guess I don't have an actual question there, but I'd love to hear about what the challenges there are and what would it take to apply some of these things very well in this domain.
So we do use a fair bit of NLP. We do use language models and some machine learning. We do a fair bit of transfer learning. So we take language models that are developed out in the wild on natural prose, and we put some training on top to conform it to engineering specifications and technical requirements. But that's not only. We also use sometimes a rules-based approach as well. So we'll use, in that sense, in a way, really we want to solve the problem. We'll use whatever technology is available to solve the problem, right? And so, we take a very pragmatic approach. A big problem today with machine learning and neural nets in particular, is this aspect of explainability, right? And that is something that in our game, you absolutely have to say, right? You can't say that something is wrong. You have to also say why it's wrong and how did you come up with that decision? Neural nets right now, it's getting better, but they're not quite there yet. At the level where you can say this requirement is wrong because of X, Y, and Z, and here's how you can write it better. Right?
Mm-hmm.
Oftentimes, neural nets will tell you why something, will tell you that something is wrong, and they could be correct. They could be almost magically correct. But if I say you have an issue in your house, but I'm not going to tell you why, you can right away, you'd be it'd be pretty valid to say, well, what the hell, man? Who are you? I'm not going to listen to you. Right? You can't even tell me why. That's non-acceptable response.
That's how I talk to my doctors.
Yeah. We could do a whole other show on doctors. I got a few things to say about that. Yeah, it's yeah. You don't want just correlation. You want causation, right?
Well, there's probably some things you could discover that where someone would look at it and they wouldn't need it explained so much. So if you say this temporal property is non-specific, make it more specific. The why there maybe isn't so important, but I assume there's other things that someone might get a recommendation. They might say, well, I don't necessarily agree with that. Or I don't understand why that would be the right thing to do. And that's where you really run into these corners and needing to explain what the tool is suggesting, right?
That's right. Yeah, that's right. So we have to be, when we use machine learning techniques and AI techniques that depend on neural nets or depend on an underlying technology that is not explainable, we have to be very judicious in where we apply it, right? And so typically we do it, the application should have a feel that is kind of like a recommendation engine. Right? If you have a recommendation engine, it's like, here's some selections. You don't have to pick any of them if you don't want, right? But here are some things that we come up with. If you like one better, use that. So something like that, you don't really need to explain it, right? It's just a suggestion. Right?
I see. So recommending alternatives gets you out of having to explain the decision, basically, because then it gives someone the option to say, well, yeah, like that's better, and then they get to make the judgment call on their own rather than sort of doing something that they don't understand. It lets the person take the responsibility for making the decision, basically.
That's right. The way we apply the technology, we always have in mind that we need the human in the loop, and we want the human to be in the loop, right? So it's not something that happens on its own, automatically, just behind the scenes, that you just get magical answers that are always correct, right? So that's not how it works, right? The human needs to be in the loop, but what you want to do is eliminate the drudgery that the poor engineer has to go through in order to do their work, right? You want to elevate them to have them make the important decisions as opposed to just the kind of mundane kind of decisions. And what we see around us a lot is a lot of high value engineers are doing very low value work. Right? And that low value work, so we have review meetings, we have sometimes 20, 30 engineers multiple days doing a big giant requirements and design review meeting, and they spend all the time talking about the syntax, right? What does this requirement actually mean as a word, and end up wordsmithing the requirement, right? Huge waste of resources when they ought to be thinking of, is this the right requirement? Have a more strategic or a higher level of conversation about what it is they're building, and are they doing it the right way, and are they building the right thing?
So maybe this is a bit of a tangent, but we think about this in the world of code as well, where like the value of having those meetings is that everybody is on the same page. And it sounds like the argument you would want to make is that using a tool like QRA is going to help your company get on the same page across the board and use the same kind of language across the board as a company, but without requiring so much time hashing over the same things over and over. Is that something that you've basically been able to witness by applying your tool?
Yeah, that's a huge use case for the tool, is just that. So some of our top customers, the way they get the most benefit from QVScribe is to embed it into the process. And so to say you can't bring these sets of requirements up to a review meeting until you meet this minimum threshold score, right? So we score each individual requirement, and then we score the container, the document, or the module, or whatever, what have you, that has to receive a certain score before it can even bring to review. Because if you can't get that score, it means that your requirements are still not in a shape that we can all understand what it is they're trying to say, so we can make a decision if it's the right thing to do.
Yeah, and it seems kind of crazy to say, I guess, this way, but like to some extent, there is no absolute good or bad in requirements, and there's aspects of code that see this as well. Like we're communicating person to person, right? If I have what I view as the perfect communication and I deliver that to you and it still doesn't make sense, that hasn't been a successful communication, right? So there is no absolute truth, but bringing everybody on the same page can presume is like, if we're speaking the same language, if you're expecting what I'm delivering, then things are going to match up better. And that's what good communication looks like, right? It requires everybody at the company. It doesn't require, if we're seeing companies struggling with writing good requirements, the answer isn't to point at the people and say, do better requirements. It's to work together to sort of make sure that what's being delivered is matching up with expectations, basically.
Yeah, I think that's exactly right. Right, it's exactly right. It is really a communication tool, and that's one of the. It's especially true for requirements because most of them are written in just text, right? And there's good and bad because of that, right? The bad part is it's just inherently ambiguous, right? It's almost the complete opposite of a mathematical statement. Although I often try to tell people that just because it's math doesn't mean that's very precise. It can be fuzzy. It can definitely be fuzzy as well. But it, or code, for example, when you write a piece of code that's going to execute, that's a very well formal syntax. It's very well defined what's going to happen, right? Assuming the compiler works right and blah, blah, blah. But English isn't like that, or natural language isn't like that, right? So that's kind of a negative. So then you may say, okay, well, what we should do is not have requirements, but have code instead of requirements, right? Well, that requires, now you've really decreased the expressive capability. So one of the advantages of writing requirements in natural language is that you have this level of expression that anyone can contribute, anyone can actually express themselves and more or less say what it is they actually mean, right? And so it is kind of a double-edged sword. The writing it in natural language has great benefits. It also has negative aspects of it as well. And often it's the same thing that's both positive and negative. One of the movements we see happening now that we think is a quote good thing is that people are starting to model their requirements, right? Not at the level of building like a functional implementation model, but modeling the behavior of the requirements, right? So I think that's kind of a good direction to go. But that's also difficult. You need to build a tool that people will actually use, right? So one example I often use in our discussions are UML diagrams, right? I always say most people would realize that if you build a UML diagram, you'll do a better job of the system in the end than if you don't do it, right? And everyone kind of realizes that, but hardly anybody does it. So why don't they do it? Well, it's a lot of work, and you have to think about it in a different way, and it's difficult, and there's time pressures, and there's this and there's that, and so we're just gonna write code, and I did something like this last year, so I know what I'm doing anyway, so I'll just go ahead and do it, right? And so, one thing we've tried very hard is not to be preachy to our customers because they have issues that they need to deal with, and you have to give them something that they can actually use. So you don't have to have a complete solution that nobody uses is kind of worthless, right? And a solution that takes you only partly of the way there that everyone uses is actually a good thing. So you should do that.
Right. In fact, actually, often we talk to people who are building tools for the developer. In this case, for the requirements writer, it's all sort of in the vein of people who are building systems. Mm-hmm. Some of the conversations we have are about how do you get embedded? How do you build something that gets embedded in that workflow that actually is used and actually is not just a nuisance or in the way? Mm-hmm. I'm assuming you're also thinking about this, given that this product is going to be within people's workflows embedded like that. Mm-hmm. I wonder if you have any thoughts on that.
We do. We have lots of thoughts on that. We talk about that. We talk about that a lot, right? And so, in fact, it's really two problems we're solving when you provide a solution, and the intent of your solution is for people to actually use it, right? As opposed to just, I don't know, writing a research paper or something like that, right? So it's a different objective in that case, right? It's not that it's bad. It's just a different objective that you want to get, right? If you want to build a tool that people actually use, so one, you have to solve for the problem, which is pretty clear, right? They have a problem with poor requirements. You want to improve it, so you have to give them a tool that actually does what you advertise. But then you have to also solve for the path, and by that I mean you have to solve it for a way that is consumable by them. That is, it fits into their workflow. You don't need to train. You don't need like a room full of PhDs to use it, especially for something. A company like us that's a product company, right? What we want to do, we're not a consulting company. We basically want to give them a product, sell them a product, and they go off and they use the product, right? So they have to be able to do it on their own. And even if they solve the problem, but it puts up too much barriers, either it doesn't integrate with the tools that they have now, so they have to go somewhere else to actually do what you want them to do before they come back here, right? That's bad. Or if it requires too high of a technical sophistication or an unusual kind of technical sophistication that they need that they don't have in house, then they just won't use it, right? Or if it's just like, a pain in the ass to use, and it's not very nice to use, not very pleasant to use, then they just won't use it, right? And it's, you can't just tell people to eat your spinach and eat your vegetables. You have to, give them a painkiller sometimes as well, right?
Well, so I wonder what that looks like actually tangibly. When we were talking to Muse Dev, which was a Galwa spin-out that actually got acquired by Sonatype, they worked on this really cool sort of analyzer that was embedded in developers' workflows to find very critical bugs that are hard to find with humans. For them, it was, I think, a lot more analyzing tools are doing this. It was, let's provide feedback on specific pull requests versus, you turn this thing on and it's just like, here's this whole world of things. Now, they provided that as well if you really wanted to dig into it. But if you do that, then people are going to be overwhelmed. They have, as you said, a job, they need to move forward. That was one concrete thing. What are the concrete things when it comes to requirements writing and making a tool more embeddable?
So it's actually quite similar to that, right? And so right now we try to embed ourselves into their workflow and to the tools they use, right? So most requirements are written in a small number of tools that they use, right? There's maybe 5 to 10 of them, not 2,000 of them, right? And so by far the most common one is Word and Excel, right? Most requirements are written in either Word and Excel. Other ones are these big requirement database systems. So Siemens makes a product called Polarian. IBM makes a product called Doors. And there's JAMA Connect is another one that is used, right? And these are essentially databases that control traceability of the requirements, control change, and just basically hold all the requirements and help you manage them, right? They don't tell you if the requirement is good or not, but they hold all the database of requirements. And so what we have decided to do in the company is embed right inside these tools. So if you're there writing the requirement, like if you're in Word, it's a panel. It's right beside your Word document that is right there. Are you building
the what might be the first developer plugin for Microsoft Word?
It's the developer add-in to Word and Excel. Right? Well, Excel already got That's Visual Basic, so poor Word is kind of left out in the middle. But yeah, you want to be right there.
I have to ask the obvious question: are you going to hide an Easter egg where you can get Clippy to appear next to your suggestions?
Clippy will not. Clippy will not appear. I will not comment on Easter eggs.
All right, fair enough.
But Clippy's going to stay dead.
All right, at least your company will not be the one responsible for reviving Clippy.
We will not be responsible for that at all. Right?
I'm sure one or two of you users just got their hopes up and had them dashed, but the rest are breathing a sigh of relief now.
Well, if you put my email in the show notes, then maybe they can maybe reach out and we can have sort of an educational discussion afterwards.
This is a pattern that comes up, I think, every time we talk to someone who's building a product. They've mentioned how much work they need to do integration to make their product usable. And it's a topic that's come up time and time again. And those integrations are different for everybody, of course. So it's a massive problem. But yeah, Muse, who Spot mentioned earlier, had a lot of work to do integrating with the various CI services, the various build systems, the various containers, all sorts of work there. Akita is dealing with from our first episode, is dealing with a multitude of integrations that live in the microservices world to make what they're doing talk to everything. And I don't know if anybody ever knows how big of a problem that's going to be starting out, but that seems to be where everybody spends a lot of their work in the technology building world.
It is absolutely something that when we first started out, I didn't even know was going to be a problem. But as I got into it, I call myself an accidental entrepreneur because I kind of fell into it. But it absolutely, I agree 100%. It's a lot. In fact, I think solving for the path, as I call it, is as difficult as the original problem you are trying to solve as well, right? So you really have to look at these both as equal partners. And in our development cycles, we're always kind of weighing the two. Which ones of these are we gonna focus on this release cycle to improve, right? It's very, very important because most of the companies that we sell to, they are, they're big engineering companies and they're very busy and they got work to do and they have jobs to do, right? And they want to get on with it. And we want to help them. And so it's no good if you help them on one side, but, oh, by the way, it has some terrible side effects. You're gonna have to totally change your workflow. They just won't do it. It just, whether it's the right thing to do or not, it just won't happen. So sometimes it doesn't matter if it's the right thing or not. You want to get it. We build tools for people to use them, so they have to be usable.
Well, it's the right thing if people use it, right? And that's what you have to realize, I think, to build a product is like your technical dream of what is right might not always line up with what people want to use, and that's something that we see out of the people who seem to be sticking with this kind of problem is they're willing to accept the challenge of helping people use the technology rather than making the technology the perfect dream, which it sounds like is something that you've embraced as well.
Yeah, it is. Yeah. The first product that we built was a lot more technical to use. And we realized that if we want to keep with this particular very technical product, we have to have a whole consulting wing, a whole services wing to help people, hold their hands and bring them along. And that's just not, that's not the company that we wanted to build. That's not the solution we wanted to offer. We wanted to offer a product solution, right? So usability then becomes a lot more important.
Change topics a little bit. Earlier, you were talking about, hey, if we solve these problems in general, to the extent that we can, then the focus of the engineers, the systems engineers, programmers, all the folks working on this stuff can be more about, is this going the right way, and are we building the right thing, versus more so in the weeds, right? You also said, with natural language, everyone can express themselves, especially if there are tools to put guardrails around it. Mm-hmm. I wonder given that, what is your take on where software development is going, and maybe what the role of programmers will be in a far off future?
Yeah, I think there's a pretty clear trend that is emerging for those who care to look of the direction things are going, right? And it's not just software development. I'd extend it and say not just software development, but systems engineering in general. Right? One is that a lot of coding and a lot of manufacturing is just going to be automated away and will become just almost a commodity, right? You're already seeing lots of automation happening now. That's going to continue. Not all coding, but a lot of coding will be like that as well, right? You're seeing some movement out there already, like in many modeling tools offer autocode, where you just attach code to a block and then it's just the product just spits out the code, and generally it's correct. It's ugly to look at, but it's not meant to be looked at. You look at the model. So that's going to continue. And I would say three big trends we see in that direction are, one, this whole idea of adaptable algorithms, which is just under the AI umbrella in general. And there is generative design and additive manufacturing, right? These things are all in that vein that go more towards automation. And so that means that the human input and the value that the humans can put into this development is much earlier on, right? And you're seeing that this is a big trend that's happening over time. It's going to keep going in this way. So earlier on in the process, into the design phase, into the requirement stage, there's going to be start moving earlier on, and so that is where we're going to see the human ingenuity and the human creativity is trying to understand what should we build, how can we solve this problem that we're facing, and how do we know that we're actually what we're going to build is actually going to do what it's supposed to do, and not do what it's not supposed to do, right? And that's where this idea of having the human in the loop and these tools are going to be almost like an aid in creation, right? These systems are becoming so complex that almost no one person will be able to ingest it all at once, right? And there was always, I can't remember who was it. It was one someone years ago talked about why software development is so hard, and the reason it's so hard is that you have to think at so many different scales, right? Down from like where the colon should be all the way to what the system is going to be, right? And I can't remember the guy's name now; it escapes me now. But that's true. It's becoming even more so now, right? So the complexity is going to be beyond the human to comprehend the whole thing, and so I see product development and systems development as being almost an act of this co-creation between the human kind of expressing their intent of what it is they want to build, and then the systems of which eventually QVScribe will be a part of this that helps them. It's like, well, do you mean this? If you do this, then here are the consequences, right? And it's a sort of back and forth where these properties emerge. The system emerges of this act of co-creation.
I will say it's a fascinating vision, and I will believe it when I see it. Although we work a lot on code generation and making sure that some of the complexity is hidden, but it's still correct. So certainly makes a lot of sense.
And it's worth saying, like in this future, right, where when we write requirements and we write specifications, we also rely on some degree of judgment being applied down the process, basically. And so there's this really frightening time, I think, along the path to what you've described, where we're starting to see automation and it gets things right sometimes, but it executes almost no judgment. And things can go horribly off the rails if you really don't nail it at the requirements, like at the very top level of the design. So that's sort of going to speak to, there's going to be a point where if that transition is going to happen, and it sounds pretty desirable, right? We're taking a lot of more mechanical work off of people and having machines do it, which is usually something, to strive for, because then there's more engaging work that people can do. But if we're gonna see that happen, we're gonna have to still get better and better on the requirement side, or the automation under it's gonna have nothing to do, or it's gonna not be able to accomplish its task successfully.
Yeah, I strongly agree with that. Right, it's not just requirements; the early stage development at the beginning, right? Of which requirements may be one of the earliest stages, but it's not just that. It's kind of that whole early stage development as well. And I think the problem that the world is facing, those problems that have a technical solution, are becoming more and more complex as it is now, right? And so it's going to tax our ability to actually even build something that can actually solve the actual problems that exist in the world.
Hey, Jordan, you're a founding member of the Government of Canada's Advisory Council on AI. Is that right?
That's correct. Yeah. Mm-hmm.
I was just curious, what's Canada up to?
So we do have a lot of, we have a lot of the fathers of AI and neural nets are in Canada. And so we do have a big history of AI. And now in quantum computing too, there's a lot of work done in quantum computing, which is also very closely affiliated with AI as well. My background is in quantum theory, by the way. And really the government of Canada, what they realized is we need to have a certain, we need input onto the policy that we want to have, right? So one is, how do you help encourage commercial activity? Like what sorts of things can we do to encourage that to happen? At the same time, there's lots of fear in the public about AI and what are the robot overlords going to take over and destroy us all. And there's also, I would say, a lot of ignorance, right? Just ignorance. I mean it in the literal sense. People just don't know. So communication is a lot of it, and also there is very little or not enough, I should say, education in universities about AI as a practice and as a career. Right now, there's so many jobs that require AI experience, and there's not enough of a supply. That's going to get worse, right? So there are all these features. Some of them are ethical, some of them are technical, some of them are commercial. And so the government of Canada, it was actually the Minister of Industry, he said, I want to have an advisory council that can advise me in all these different aspects and sort of take a big picture so that we don't inadvertently set these policies that we think are the right ones, but it's going to set the country back. We're not going to know it till like 5-6 years later that, we just screwed ourselves from these policies, right? And so I was very impressed with the cast. If you go on the website, you'll see other people in there. It's a very very impressive list of people. And I was also have to say, I was impressed with that the government of Canada actually took it seriously. And they actually, they actually wanted to try. They do want to try. They do try hard to actually listen to people and actually make a difference, to actually inform policy. So it was, I would say, refreshing, let me say, right? And surprising in a good way. And incidentally, explainability of AI was one of the important things. So I mentioned explainability for requirements, right? Which I think kind of makes sense. And I'm sure the kind of stuff that you guys do, explainability also is a big, this reasoning behind the system's decisions is very important. But, this may be a bit of a tangent here, but you can imagine that if you're applying AI on policing or sentencing recommendations, right? Now it's much more, explainability becomes a lot more important now, right? So, you can't have a recommender engine for sentencing for reporting.
Yeah, and more immediately, self-driving cars have a lot of need to explain their decisions as people go back and audit the decisions that they have made or not made. So there's a lot of immediate demand for that kind of thing that we see for sure.
Yeah, and self-driving cars is also another tricky one because obviously it needs a great deal of trust for the public, right? Whether the trust is well-founded or not, or whether it's misplaced trust, whatever, trust needs to happen. Otherwise, nothing's gonna get done. And the tricky thing is, if you don't have a population that understands the trade-offs and understands the technology at some level, they don't need to have a mathematical understanding. But if you have a self-driving car, it's going to make mistakes that a human will never make, right? But it's also not going to make mistakes that humans often do make, right? So it's going to be a trade-off, right? So nothing is ever just yes or just no or just good or just bad. It's always like a big, not even levels of gray. It's just technicolor. It's complicated.
Again, this is definitely a tangent, but what does it mean to make a mistake, right?
Mm-hmm.
You're trying to avoid hitting somebody and you go on the side of the road, right? You cross the yellow line. Is that a mistake? How do you tell a self-driving car that's not, that's not? And how do you then do that whole thing for the hundreds and hundreds of different scenarios that you find yourself when you're in the road?
Yeah. And
good luck with that.
Yeah. And not all these solutions are technical in nature, right? And so, you see now sometimes you hear every once in a while a report where a self-driving car, it mistakes, it doesn't see a bicycle because there was a truck behind it. And it didn't see it because it kind of blended in. I thought it was part of the truck, and it just hit them. Right, that's an example of something that a human would never make. It's very clear that they would never make that mistake, right? But humans fall asleep at the wheel all the time, right? And a computer will never actually make that kind
drive
of mistake,
drunk,
right?
all that.
That's
stuff,
right. A computer will never make that mistake, right? And so it's those are very difficult decisions. I'm glad I don't have to make them.
Mm-hmm. Well, Jordan, it was really good to talk to you. Thanks for joining us today.
Yeah, it was my pleasure. A lot of fun.
Great.
It indeed was a lot of fun. This was another episode of Building Better Systems. We'll see you next time.